This presentation addresses the value of VISTA, the Veterans Health Administration. It addresses whether the value added to VHA is caused by or merely related to use and investment in IT. It is important to evaluate the value of an IT investment. As with any investment, it is necessary to have accurate data to help make an informed decision. Many resources, including time, effort, and money, are devoted to IT investments that often do not yield the expected results. Many investments in IT fail because their value is not properly predicted upfront. The use of technology is integral to business today, and the role of technology and electronic health records is likely to rise rapidly in the United States. It is therefore vital that administrators and other decision makers have an objective means to evaluate and predict the value of their investments. VISTA stands for the Veterans Health Information Systems and Technology Architecture. It is the award-winning information system used by the U.S. Department of Veterans Affairs Medical System, the Veterans Health Administration. This health information technology system is a valuable tool that administrators use to deliver quality care and gives VA patients an integrated inpatient and outpatient electronic health record. As of the end of 2006, VISTA had 7.7 million enrollees. It is one of the most widely used electronic health records in the world. In this presentation, we will assess the data you see on the screen to evaluate the business value of IT. The data come from VHA's website and include fiscal year, budget, number of records, and use data. Traditionally, financial analysts would use return on investment ratio to predict the value of the investment in VISTA. This approach, however, fails to be complete, accurate, and unbiased because the analyst chooses which potential financial benefits and costs should be included in the analysis. The analyst may decide to highlight that the technology will reduce paper costs, yet he may fail to include the financial implications associated with the time and resources it will require to train staff who will use the new technology. Rather than use the inherently flawed method to assess the business value of IT, this presentation uses the novel approach presented by Alemi et al. In the 2009 proposal entitled Proposal for Causal Analysis of Return on IT Investment. This method of analysis is more objective because it relies upon the quantifiable impact on the organization's outcomes. Specifically, it looks at the relationships among cost, use, and revenue, and then determines if these relationships are likely mere correlation or if they imply causation. Using this methodology, we can assess the data. This scatter plot shows the relationship between revenue and IT investment. Performing a linear regression yields a sample correlation coefficient, or R, of 0.89. The square of the sample correlation coefficient, R squared, is 0.80. For the relationship between revenue and use, the sample correlation coefficient is 0.57 and R squared is 0.32. For the relationship between use and investment, the sample correlation coefficient is 0.76. R squared is 0.58. The closer the correlation coefficient to 1, the stronger the correlation. As the coefficients indicate, there is correlation among the data sets. But now we must ask, do these data indicate causation? Two possible causal relationships exist. First, perhaps an increase in investment led to an increase in use, which led to an increase in revenue. Or perhaps an increase in revenue led to an increase in investment, which led to an increase in use. To answer this question, we can perform a causation analysis. Taking the correlation between investment and revenue and subtracting the product of the correlation between investment and use and revenue will yield 0 if this is the correct sequence of events. Likewise, the second equation would yield 0 if it describes the correct sequence of events. As you can see, the first equation yields 0.46, which is not close to 0, so it is unlikely that increase in investment led to an increase in use, which led to an increase in revenue. The second equation, however, yields negative 0.12. Negative 0.12 is close to 0. This indicates the likelihood that an increase in revenue allowed for an increase in investment, which was followed by an increase in use. The data set in this analysis are not perfect. Only 3 data sets are considered, and there are undoubtedly additional data that could be included. Additionally, there are only 7 points per data set. But this analysis offers a more objective analysis that accounts for all costs and does not subjectively pick and choose which costs and benefits to include in an analysis.